Hi Dinesh, thank you so much for joining. So, guys, just to let you know, we have muted by default. Uh, if you have any points that you wanted to talk through, if you have any questions, please drop your questions in the chat box, and we will take up the questions after the once we complete the presentation. Thank you, Dinesh. Thanks for the response. Hi, Avinash. Thank you so much for joining. So we have 3 more minutes here, and then probably we'll wait until like 5, and then we can get started. Just give like 5 minutes benefit of doubt for people who are joining a little late, and then we can start sharp at 5, and then we can kick start for sure. We have 1 more minute here for 5. Uh, but thank you guys. I mean, thank you so much for joining, guys. I know it's a weekend, and you spend some time to upskill yourself, understand the concept of functional safety here. So thank you so much for joining again, for everyone. So Anudeep will give them like 5 more minutes, and we'll start at sharp. Probably like five. We can start off for sure. Yeah.
Okay, Ram. Okay, Ram.
So we have around like uh, 13 participants here that I can see at this point of time. Let's wait for 5 more minutes, guys. Thank you again. Thanks again for joining in, guys. I was talking about it just 2 minutes before, but thank you everyone for joining in. And then I know it's a weekend, and you decided to come down here to understand what we're presenting in functional safety. So thank you so much for everyone joining in. Just let's give it like 5 more minutes for people to join in, and then we can get started for sure. Just 5 more minutes. Meanwhile, if you can hear me loud and clear, please type yes so that I can understand that okay, you guys are listening to me. You don't have any issues with respect to the audio problems. Just say yes in the chat box if my audio is loud and clear. Perfect. Perfect. So let's give like 3 more minutes and then we can get started. So while we wait for others to join in, we wanted to let you all know that we are really happy that you're here, and we are really thankful for your time and for your participation in the event for sure. And we wanted to make this session as interactive as much as possible. So if you have any questions, please drop your questions in the chat box, and we will try to answer those questions for sure. And by default, we have muted you, considering the number of participants we have muted at this point of time. But if you wanted to talk or if you wanted to ask any question, please drop your questions in the chat box again. We will try to take up the questions at the end of the session, and we will try to get an answer from the speaker. So let's give like 2 more minutes, and we can get started right there. All right, I think we have reached close to 5-4, but again, thank you guys. Thanks a lot to everyone for joining in. So today, what we wanted to do was we wanted to take a very key topic in the market, which is very hot in the market, how the functional safety management, the ISO 26262, fits in the product development lifecycle, right? I mean, you have different standards that's coming in the automotive industry. You have ISO 26262, you have IATF 16949, you have SOTIF, you have ISO 21434, which is the security standard, the cyber security standard. And we also have the base standard, which is the automotive spice. So there are different standards that's coming in the market right now, and we wanted to touch upon a key topic on how the functional safety actually fits in the product development lifecycle. And we want this session to be more interactive. If you have any questions, please drop your questions in the chat box, and we will try to take up all the questions at the end of the session for sure, as much as possible. And if we cannot answer the questions, we will definitely reach out to you offline, and then we will let you know, let you know on the response for sure. And again, for the new participants who have joined in, we have defaulted. I mean, by default, we have muted the audio. If you have questions, again, please drop your questions in the chat box. By this, I would like to introduce our speaker for the day, Mr. Anajib, who has a very good experience with European OEMs and also US OEMs in the functional safety consulting, and who's currently supporting Nortech. So, Anudeep, over to you. Please take over and you can run through the slides.
Thank you, Ram. Thank you very much, and thank you very much to everybody who are participating here, and to everybody. Good morning, good afternoon, and good evening to people who are located in different locations. And so here we are trying to, or which we are trying to address, are not like an very much introduction sessions, which all other trainings are being there. So here we are trying to mainly focus on where the organizations, different tier ones, OEMs, service-based companies are coming into the picture, and how they are trying to introduce functional safety into their existing organization structure, and how they are formulating it. So that's the reason we are not going for an introduction section saying that, okay, so and so our functional safety has been started, so and so, and because of this we are doing this. So reasoning, so that reasoning we are not going to do here. So here are some of the sneaking into the peak for coffee table, what are the contents we are going to have. So how the V model is going to rephrase or restructure into the ISO 26262, and understand what are the different types of roles and responsibilities there in the functional safety domain, and how the organizations are structuring them, and different deep in sorry different departments are interfaced in functional safety, and what are the cost factors for it, and how it is legally binded, and legally implicated things are there in it, and see the complete functional safety life cycle from the top to bottom, and different types of interfaces going to be there, and how the OEMs are going to be approached, and how we can develop a safety element out of context, and how we can develop a competency management inside it, and how what is mean by safety culture, and how we are going to develop that, or how we can develop that, and SL impact on production. Why? Because this is one more factor where a lot of the trainings will be missed, and that is the one more topic we want to address, especially for the OEMs and tier ones, and our integrated plug-in play approach, how we have in not tech, okay, and many other more inside it. Okay, so from this I would say that these are the topics typically we are going to cover, and now I'll jump into the topics. So this is the one slide we are going to skip now. Why? Because this will be addressed by Ram again later. So we'll start with what are the different types of roles in functional safety are there. So when we see in different types of organizations, they have different designations. They say that functional safety manager, subject matter expert, and safety engineer, and technical safety manager. So based on the organization, they have different designations. But at the end of the day, if you see, we'll have only two things. One is safety manager, and another one is safety engineer. Who will be the responsible for developing or implementing the artifacts or work products of a functional safety. Those are considered as safety engineers. Like they can be in the system level, software level, hardware level, or the vehicle level. And there will be a functional safety manager who will be accountable for all the artifacts and anomaly reports, and safety planning, DIA agreements, and responsible for the entire safety of a product. But based on the organization structures, these designations and naming conventions, these all will be changed. But basically there will be only two. One is safety engineer and a safety manager. Okay, based on that, those responsibilities will be changed. Okay, so these are some of the typical architecture or structures which are assigned in a OEM or a tier 1 company. So usually you will have a so you will have a safety management group who will be reporting to directly to an OEM, or directly to a CEO or a department head, or to a vice president, or some other. So in the business rules, so typically this will be for a tier 1 structure. Why? Because you will have different business units, like if you take ZF, or if you take Bosch, or different tier 1s, they have different business units for defining, or for different products, like steering lock columns, and braking units, suspension units. So based on the business units, you have individual business unit functional safety management teams, and based on that, again, you will have for individual project, you can have an individual project team for that one, where the individual safety team will be working for the individual projects based on what kind of suppliers they have, and how much responsibility they are having, and how much it has been distributed to the suppliers. Similarly, there is another structure here. So you will have a business unit, a safety management team, and typically this one is considered as a core team. And this team will be taken care for individual projects. You will have a project safety teams, and in this engineering teams, all the safety engineers will be integrated, and the instructions will be followed from the safety management team. Okay, and this will be this will be a parallel unit for an engineering team, but not directly integrated into it. Okay, so these are the two different types of structures are there, but there are many other structures we cannot address at this small discussion, all of them. So based on the structures and approaches, and everything will change. Okay, so these are the some of the responsibilities we can say for a safety manager to take care in a project. So we need to based on the project scope and project boundary, the functional safety manager have to take care of prepare a safety plan and perform a dia, develop a development interface agreement, that is called as dia agreement. And based on that, functional safety manager have to coordinate with the other engineering teams to make sure that all the required information has been transferred to the safety engineer. That means basically a engineering team. So engineering team will develop their system architecture and system requirements, software and hardware and so on. But based on what they are developing, that means they have different meaning of approach. That means a system architecture can be developed based on an element format or a functional format or a requirements format. Okay, so there need to be a design guidelines from the system architecture which need to be forwarded to a functional safety team. And from the functional safety team, they have to understand that, and accordingly they have to analyze the structure, and they have to develop their perform some fmeas hara analysis, and based on that they have to come up with the technical solutions. Okay, then next, if we go for the safety engineers, so these are the some of the roles and responsibilities where a safety engineer have to work on. So he will be responsible for performing an fmea, developing a technical safety concept, functional safety concept, and developing a safety concept for software and hardware, and giving to the relevant test cases and validation, and then transfer it to the production teams. Okay, so these are the if you take a functional safety as an in a complete organization, it has to coordinate with production team, quality team, sales team, supply chain, legal department, and also the engineering team. So engineering team is the primary one. Why? Because this is where the product is getting ready, but parallelly it has its equivalent weightage to the remaining teams also, to make sure that our engineering department is doing right and the product is being transferred to a OEM or from the end user properly. Okay, so there is a very important thing is cost factor. We always see that functional safety, that safety is given the highest priority and next to the than the cost. That's why functional safety is highly unlikely need to be independent of the engineering division. Why? Because from the engineering division, you should functional safety team should not be influenced by the engineering factors and business unit factors or cost factors. So here we have some question saying that does the development the whole product according to the SL rating? No, it is not necessary. Why? Because the safety, based on the safety goals, we see only a particular functions are influenced or safety critical, and those functions need to be developed according to the SL rating. So the entire product need not to be developed as a safety. Okay, will the cost be like on a normal project? Definitely not. Why? Because when certain functionalities or certain functions or certain features are identified as a safety critical, then it is very much dependent that all the redundant architecture need to be followed in that. That means the components or the hardware components for a particular flow of that functionality, you need to change it to the redundant functions or redundant components in that. So because of that, the cost of the product is going to be increased. There is a small example here. So if there is a 30% of parts of electronics are affected with the affected while leading to an ECU samples piece price, that is into 3 into 2. This is just an example, but this is not the exact factor. Okay, this can change based on which type of product and which type of SL level we are implementing. So this is an example for an SLC, and similarly there is an into 4 for SLD components. Okay, so to avoid these factors, what we can do? So for that one, what we can do is, while designing itself, if we are able to identify what are the possible failures and what are the possible effects or critical effects it is going to be there while designing itself, then you can have a cost control. Why? Because at that time itself the critical factors are covered, and some people can say that it is an over engineering, but this is the fact how we can reduce the cost in one way. Okay. And is it too expensive so you can leave the software or hardware or safety factors and just you can implement your product and give it to the customer? No. If you already identify some gaps and some technical problems which there can be there, and still if you avoid it and if you give it to the customer or end user, then it is legally binded, and you will be the people who will be responsible for any cause or factors inside it. So to avoid that, functional safety manager or core team will take the responsibility to how we can avoid such kind of things using some anomaly reports and performing some at the end of the project we have some safety case for which factors this product is applicable and how it is applicable. So those are used in those scenarios. Okay. And these all things are adopted to the European legislation, and national legislations. So there is a complete separate presentation for the legal factors, what all the norms are there and how it is covering and where it is covering. If you take generally as a functional safety, it is not mandatory to implement in every project, but if it is identified to there are some critical factors or critical safety parameters need to be taken, then it is needed to implement, or else there will be a lot of legal issues once there are any recalls or damages occurred. Okay, this is one of the norm or article we can say as an example I have given here. So these are the corresponding product liabilities. So Article 1 and Article 6, which gives us an very light example saying that how the legally it is liable with the product owners and liable towards the OEMs and liable towards the service-based industries, basically. Okay. So these are some of the needed homologation files, as Ram has mentioned in the introduction, in the initial introduction also, that we need to have IEC 61508 for the general safety, and for the automotive specific safety we have ISO 26262, and SOTIF is for the intended functionalities, and ISO 13849 is for the manufacturing and production part, and ASPICE. Sorry, unfortunately that is missing here. And now recently we are also getting ISO 21434 for the cybersecurity, which is going to be a regulation. Unlike functional safety, that is going to be a regulation from 2024 onwards. Okay, so now when we go into the safety life cycle, so this one I think most of the people have seen this one from the ISO standard, and what all the chapters are there and how it is flowing from the many introduction trainings are there. But anyway, I'll go through, show you what are there. So vocabulary is the first chapter. Why they have maintained the vocabulary? Because globally and even individually in an organization, everybody have their own understanding or terminologies throughout every project. So to overcome the confusion between what they are speaking, that for example, if you take element or modes or states, if you ask a software engineer, they have a different understanding what is mean by mode and what is mean by state. And when we go for an system engineer, the modes and states, they speak in a different terminology. Okay, to avoid the conflicts and misunderstanding and everybody speaks the same language, that's the reason the vocabulary came into the picture. And then we have a complete functional safety management, what the manager have to take care of in the complete life cycle. And this is the concept phase, which is also called as the vehicle level. And here we have our system level, hardware level, software level, and production. And these are the supporting processes to run the complete life cycle. complete life cycle, what all the things a project functional safety manager have to take care of. And these are the supporting methodologies or guidelines for doing different analysis in different level of development or different phases of development, like vehicle level, system level, hardware and software, and production. And in the second edition, they also introduced a specific guidelines for semiconductors, what they need to follow, and also for the motorcycles. Okay. So this is the typical life cycle which we directly get it from the standard, which is a water flow model from top to bottom. But 90% of the industries cannot follow this one because of the work culture or the work, how they proceed to do their system development or software development or the hardware development. So that's where we come into the picture, how we can introduce or which type of methodology it will be very useful for us to approach to lead to a safety life cycle, and at the same time safety certification. Okay, so if you take an SOP project directly from an OEM, so usually you will have a system development and software development and a hardware development. So you will get a system requirements from the OEM and you develop it. So in that development, so these are the factors which we need as an input for a safety team. So you need safety system functional block diagram, and what are the operational modes and modes to function linking. So which mode is working in which function, and function to requirements linking, and each function entry, operation, and exit logics. These are the inputs needed from the system to the functional safety team. Okay, and then we have an item definition, HARA, and functional safety concept. These are on the vehicle level, but OEM will give us the OEM will be the accountable person for item definition and HARA, and we will from HARA we will get our functional safety, our safety goals and safe state and FTTI timings, what need to be achieved in the functional safety concept. So we need to develop our functional safety concept on existing what is the system architecture, and based on that we propose what is the functional safety concept, how we can achieve our safety goals and our FTTI timings and reach the safe state. So this is our evidence. So always these are considered as our evidences of whatever we do in our safety life cycle. Okay, so from functional safety concept, we see that technical safety concept. So technical safety concept speaks about how we can achieve the required functional safety concept in terms of signals and architecture, little bit lower level architecture. Okay, and on this we perform our FMEA and FTA analysis, and then whatever the new findings are there, those will be need to be reflected back in the technical safety concept and functional safety concept, and they need to be updated in the requirements, and then based on that we will have our safety HSI, excuse me, and then the following requirements will be transferred to the safety software and safety hardware, and once that is completed, that will be given to the production. So here you will have our initial safety case, and then it is given to the production, and the production life cycle there, where we'll follow up with the DFMEA, PFMEA, and control plan, basically. Okay, in a general SOP project, this is the usual flow how we will have it. Similarly, if we go for the safety element of context, so usually we develop a safety element of context when we don't have an OEM, but still we want to certify our product as a safety product, and which will be sold as which will be given to an OEM or a tier one as a off the shelf product. Okay, and then according to their requirement, they have to do further some more activities. But usually a tier one, this will be a flow for mainly for a tier one, and whereas where the service-based companies will provide the resources and so on. So usually you will have a concept. Based on the concept, you will see what is the functionality of it, and based on the functionality, you identify what is the logic you need to implement. And once you have these things, you will either do a simulation or define or try to develop a pre-prototype. And once you have that one, you understand that your logic and functionalities are implementing properly, then we go for a software development and a hardware development, and based on how we have our software and hardware, we try to develop our system. Once we have this one, then we try to start our item definition and HARA based on the vehicle assumption. That means what is the targeted vehicle, for which targeted vehicle we are developing this product. Based on those assumptions, we'll try to perform our define our what is our item boundary, and based on that we'll perform some hara or hazard, and then we'll have our top level safety goals, and based on that safety goals we'll go with the complete life cycle. Okay, this is what we happens in the safety element out of context. So this is one more safety method we come up with. Why? Because most of the Taiwan companies, they don't want to develop the complete functional safety life cycle, because it is very cost effective immediately before having an OEM. Okay, so before that itself, before OEM comes into the picture, they need to show some artifacts or some work products to the OEM, saying that we have something already in the functional safety, we identified so and so, and now we are ready to or to get a project, basically. So with irrespective of whatever the system architecture or system requirements you have, initially we can define what on the base functions which are identified in a product. Based on that we can have our assumed system block diagram and operational modes, what it has to be there, and assume a targeted vehicle, and based on that we don't flow the complete process, but we only derive the or define or create the work products here. So you'll have an item definition work product. We'll not go to the complete life cycle of this one. Okay, just we'll perform hara work product hara, and we'll have our results and very high level functional safety concept, and we'll have only up to except implementation of the software, remaining all other work products we will be preparing. This will have almost all 60 to 70% of content inside it. Okay, where we can show this one to the OEM, and then we can have a project, and then we can go according to their requirements or their targeted vehicle. Okay, this is one approach we have seen, other than SOP project or other than safety element out of context implementation. Okay, so that is one way. And second thing is improving the competency management in this. Unlike other competency implementations, functional safety, there are some miscommunicated or misunderstood about the competency management here. Why? Because for the functional safety, even though if you have a functional safety certificate in your hand, it doesn't mean that you have the competency in that one. Okay, in functional safety certifications, they only states that you know what is there in functional safety. It doesn't says that you worked on it and you have experience on that. Okay, that's the reason, even though now functional safety has been introduced more than a decade, still it is difficult to identify a right person for functional safety who of a functional safety to get a functional safety manager or a functional safety engineer. Okay, so most of the time the people in the functional safety area, they will be working dedicatedly to a particular area itself. That means those people mainly will be working on FMEA itself. They'll be working on FTA itself. They'll be working only on the system level. They'll be working only on the analysis part. Some people will be working only on the deriving the requirements. So because of that, most of the people will be missing the big picture, how the vehicle looks like, how our products fit into the vehicle, how our product can fail. Okay, and when you try to assign the functional safety activities to the same system engineer or a same system analyst or a software engineer or a system engineer, they cannot directly integrate these functional safety competencies. Why? Because when you see engineer, a system engineer or a software engineer or a hardware engineer, first they will think about the product, how the mindset is basically. So they see that okay, how good the product they can develop. Okay, they see that okay, to make this one, how good, what are the things to make it perfect or good quality, what are the things I need to introduce into it. But when you go to a functional safety, the engineer will think in a way that always how bad it can do. So he will be in that mindset itself to analyze, and that's where it is difficult for a single person to do the both the activities. But at the end of the day, the over in the functional safety we call a safety culture. The safety culture at the end of the day in the timeline is, its goal is to achieve that. That means the same person need to achieve, need to think both in the positive direction and the negative direction, but that will come only in the over the duration. Immediately it cannot happen. Why? Because why? Because a particular engineer, he's continuously habituated to that one. Okay, so that's the reason there should be a continuous trainings for the engineering departments, how they have to achieve this mindset to overcome all the problems. Okay, so that's where the safety culture comes into the picture. Usually the safety culture will be taken care by the core team or a safety manager, based on the structure, how the organization structure is there. At the same time, core team structure is there. So there they have to come up with how the leadership need to be taken care, and how the problem resolutions need to be there. This is where the anomaly reports comes, and how they need to be maintained from project to project and OEM to OEM, and personal accountability. So who is accountable to which activity, how much they're responsible in the legal point of view, and at the same time in the organization point of view. So working process, so how the workflow need to be there according to the project to project, and how the inputs we are getting, and which level of things are there in our scope. So similarly, these all questions need to be satisfied for the to achieve a good safety culture. Okay, so these are not like a stepping stones, that these are the things definitely you need to follow, but these are the things looking into the different organizations, and coming with the different projects, we assume that these are the things need to come into the picture to make it good safety culture. Okay, to achieve these things, a functional safety manager, why? Because in typically I can say that functional safety manager is, he's, I mean, it is not only that he's responsible for the management, he also need to have a good technical knowledge to be a safety manager, to be a safety functional safety manager. Why? Because he also need to look into the technical things, at the same time into the documentation, at the same time the time plan and agreements. So it is not that he look only purely into the management. Why? Because functional safety manager is accountable for whatever the workers are being prepared. So technically also he need to be strong there. Okay, that's the reason he need to be invited into the all project related meetings, and change managements or plannings, and understand the scope. So in those all areas, if he's been part of that, only then only he can give a proper judgment or a proper anomaly report or a proper safety case for a particular project. Okay, that's why he is one of the stakeholders who will be having certain weightage. If for example, if it is an SLC or SLD compliant product, then functional safety in manager has the have the authority to say that okay, this cannot go to the production until or unless OEMs agrees for these anomaly failures. Okay, of course that still depends upon the organization structure, how it been followed, and what kind of transparency they are following. Okay, so that's up to the safety culture to understand that those all parts come into the safety management. There is a different safety management training for that one, and make them to understand what all the different points are there. Another huge area is acceleratings for the production, how it is going to impact, and this is also one more important factor which will affect the tier ones and OEMs in their production. So if it is a QM product, so you'll have a general general production line. But when we go for an accelerated components, so when you see an OEM, he will have different types of suppliers and tier ones, and from tier ones again they have different types of suppliers. So if you take one software and hardware development, which is a safety critical one, then they need to follow integration testing at each step. Okay, once you have an safety critical thing integrated here, then when you integrate it into a power pack, then again you need to do some minimum test in production, and then whenever the integration stages happen, every state you need to have a testing, and once the final integration happen, then you will have an end of line testing. Okay, there will be a separate session for this one, how where it starts and how it flows and where it ends for the production. So this is just a glance for to understand. Okay, for a safety critical one, you need to have a different markings for it, and whichever the safety circuit will be there, for that there need to have a different marking, and how you are going to decompose that part, how it is going for the decommissioning, and how it is going for the how it is being performed for the till the end of its life cycle. And there will be a service manual, and there will be an instruction manual, how it has to mount, and so on, so on, so on, so on. So this part itself is a very huge topic again. Okay, so in that's how the production is there. And then when we go for the SL ratings, I know this is a similar topic where you have SLA, SLB, SLC, and SLG, but on what basis do we give this? And if you take a steering column itself, steering column or a braking system, or if you take a battery management system, for these all individual products, OEM to OEM, the SL rating will vary. Why? Because based on their analysis for a particular targeted vehicle, this SL rating will change. They will understand that they will come to a conclusion. Okay, my system can be an SLA, SLB, or SLC, or SLD, based on what kind of hazards which is causing an impact on the end user. So if a particular product, if it is impacting only an external damage on the vehicle, so usually this one they will keep it as SLA. But this one depends upon the different factors. They will always consider where the product is, or where the my product is sitting in the car. Okay, and if it fails, how it is affecting on the people who are sitting inside the car. Okay, and if you are having end up with a minor damages or injuries, then SLB. If it is going to be critical damages, then it's SLC. If it is going to be an mortal, more to a person, more chances where a person can die, then it is going to be the SLD. But how these things are defined, that you will see in the hazard analysis, hazard or hazard analysis. Okay, so these are some typical examples where most of the OEMs have defined them. They can be as an SLA or SLB. So many OEMs are defined. Some people can say that power windows can be SLB also, but most of the OEMs will define as power windows as SLA. So infotainment system as QM, and headlamps as SLB, and braking systems as SLC, and steering lock column as SLD. Okay, and if this power window fails, and some other OEMs mention that as it is SLB, and if you have defined that one as an SLA, in court of law they will question you, definitely saying that why did you did not implement this one as SLB when other OEMs have implemented as SLB. And there again you will have a problem if the functional safety manager didn't give a proper, if he don't define it properly, why it is given as SLA, then it will be a huge lawsuits on the particular company. Okay, so the here in the time, always they say that sometimes they say safety and security. So because of the terminology, sometimes they get confused. So here I also want to define security is always protecting against the attack. So security is like our cyber security. Okay, safety is our functional safety, does not cause harm. So to avoid such kind of harms, we develop our functional safety. So you can say this one as static and this one as dynamic. A simple terminology where our engineers can understand. Okay, but don't take it literally. Okay. So here in functional safety, we have active safety and passive safety. Active safety means the systems which help you drive safe. Okay, passive systems are which will protect you in crash. Okay, here are some of the examples. where you can identify, and based on this you can identify yourself which category product you are developing. Okay. So in the management of organization, so this is how usually we would prefer to have a functional safety structure. So you will have an functional safety manager which is independent from business, and the functional safety engineers need to report it to the functional safety manager, but not to the project manager. Why? Because the identified failures and everything need to be identified them and need to be reported to the project manager. If he don't agrees, or because of the cost factor or technicality factor, if he's not accepting because of the cost increase or other factors, he can functional safety manager will be directly reporting to the core team or the department head or director or a CEO. So they will be reporting directly to them. Okay. So because of this, you will make sure that your product, whatever you are developing, is making sure that you are developing a safety product. So basically the independency, but it is not always necessary it has to be like this. It can also be like functional safety manager will be there and engineer will be sitting in both the same area, but safety engineers will be reporting to the safety manager, and engineers will be reporting to the engineer. But safety manager need to be independent to make sure that your product is being not influenced by any other factors. Okay. Typically we'll be having this, you'll have a management phase and you'll have the concept phase where you'll be developing your item definition, hara analysis, safety goals, functional safety concept, and we'll review it. And then you'll have a plan to how we need to do a technical safety concept, technical safety requirements, and HSI, and prepare a verification and validation plan for the complete system. And then it will be given to the hardware and software phases. And then the parallelly your verification validation planning will be followed accordingly. Okay. So typically you'll have in a spice V diagram, usually you'll have your system V model and software. Now hardware spice also came into the picture, so hardware also will be integrated. So here we have defined all, not only electronics but also mechanical factors and also the ISO factors, how the vehicle level can be integrated into the complete flow. Maybe Ram, from here, I think it would be better if you take over. Uh,
Of course, of course. Thank you so much for that,
yeah,
Anadeep. I think we have few questions on the screen. So probably what we can do
absolutely.
is we can take up the questions real quick, because with this we are trying to wrap up with the functional safety part of it. So
That's right.
there are few questions that is coming out right now in the chat box. The first
Mhm.
question that I have is, we noticed that sometimes in a project we attach ASIL levels to the product, which is basically the higher ASIL level. We refer that
Right.
the product from the safety perspective, product
Mhm.
achieve ASIL D, for example. Is that really correct
Mhm.
from your perspective?
Yes, the SL rating is given for a complete product, not for a individual requirement or a individual development. It is the SL rating is given for a complete product. That's right. And that's,
Awesome.
if you are unable to achieve that one, that's where we do the SL decomposition, and that's where we have the splitting of SL rating to the sub development phases for hardware or software.
Thanks for that, Anadeep. I think the next question that I'm getting here is,
Mhm.
I do have one question. Is functional safety somehow connected to the product security? If yes, can you give an example on how it's connected to?
Okay, it is yes and no. Why? Because when we say security, when we say product security, in which context we are talking about? So if the product security you are taking, for example, if your product is not directly exposed to the external world, okay, you are only communicating to the sub component of a, for example, if you have a VCU and if you have an BMS, and if the BMS is only communicating through VCU, vehicle control unit basically, then the product liability and product security is different. And when your ECU itself is if your BMS itself is communicating to the external world with some other factors, like you have your OBD, linking and OBD testing over there, and diagnostic testing and flashing even at the end user when you go for a servicing and so on. So the product liability or product security will be different. Okay, and when you have a cyber security in that one, this the approach will be different. And how I can put it, uh, typically how you protect your safety inside it. um, I know it. I'm rather than solving your question, I know I might be confusing you also at the same time. So sorry for that. Why? Because this is a little bit typical or a critical question. Why? Because
No, I
when you
think you
say
made your point. I think you got a very good point, right? I mean, the first point that you talked about with respect to the context of the element, right? Let's say that
yes,
it depends on the scope in which scope of your system. If your
that's
scope
right.
of the system, let's talk about the BMS, or if you talk about EPS, fast steering solutions,
Mm-hmm.
or infotainment solution. If the
Mm-hmm.
system has an exposure to the outside world where you see a threat in it,
Mm-hmm.
right?
Yeah.
Then, of
Yes.
course, there is a dependency between the safety and security,
Mm-hmm.
where we may also have to do a technical threat, or not the technical, the threat analysis and the risk assessment to identify
Yeah.
the threats, and then you identify the action plan to address those threats. So yeah, I
That's
mean, it depends on the context of the system. You're right.
yes. So typically, when we have something like this as a, come on, why am I? Mm, I don't know why my pen is not working here.
While you do that, I've been hearing that there were some technical issues in joining in. Sorry for that, guys. I mean, we will definitely take that feedback. We'll work on it and make sure that it is fixed next time when we do this.
Sorry, guys, my whiteboard is not working properly. So when we say this is one product, some product, okay, and in this, if you take as security, security is applicable for complete product, not for a particular component. But functional safety is applicable only to the identified functions. Okay, if the product security is or product security is affecting these functionalities, safety functionalities, yes, then there is the problem. Okay, that's why we have a secure boot or a secure RAM location or secure memory locations, and based on that we implement it. And that's where we get our three-layered architecture or eGAS architecture, and how we implement it in the product, sorry, in the software structure.
Perfect. Perfect. So one more question that I have here is: will the vehicle
Mm-hmm.
assumption targeted vehicle approach is recommended
Mm-hmm.
or only option for the platform products? I think the question is more on what is the best approach that you can propose. We talked about the SOP, we talked about the element of
Mm-hmm.
context. For platform
That's right.
products, what is the best assumption or best approach that you recommend?
Okay, so basically the safety element of context is mainly for platform projects itself. So in the platform project, what you want to define and which targeted vehicle you want to prepare that one for. So some products are specifically for an electric vehicle. Some products are mainly for hybrid vehicles. At the same time, we have in electric vehicles also different architectures, and also in hybrid vehicles. So which high level architecture you are targeting, so based on those assumptions, we need to perform it, or based on those, we need to consider what kind of assumptions we need to take.
Perfect. So the next question that I have is: what is the difference between the product safety manager and the functional safety manager? And we've been seeing that this role is being overlapped in our organization. So what is your take on it? I mean, have you seen the scenario where
Okay.
you have a product safety manager and functional safety
Mhm.
manager?
Yes, I have seen, but at the end of the day, I'm saying there is only a functional safety manager because of the designations which they have given. Because of that, roles and responsibilities are going to be splitted. That means when you say a product's functional safety manager, he is accountable for the complete product safety. Okay, when we say that means, for example, there is a steering lock column and there is a production safety manager for that steering lock column. That means in that company, whatever the safety steering lock column products are developed for different OEMs, he is responsible for the overall product. Okay, but a functional safety manager will be responsible only for that particular project.
Yep.
Okay,
All
but
right.
that
Thanks for
varies
that.
from the organization to organization how it's been split. So the
Yep.
functions product owner will be a part of functional safety core team, and functional safety manager will be who will be following the rules and process guidelines, and what are the guidelines which were defined by the core team.
Perfect. Awesome. Thanks for that, Anki. So the next question, I mean, the next and final question that I have is ASIL determination, right?
Mhm.
ASIL determination is usually done for any functionality or it's done for the product.
It is done
I
for the
think we
product.
answered it. Yeah, we
Yes.
answered it already. So, and I think I'm getting one last question again here. Some
Mhm.
OEM involved in calibration. Does this also means that we need to include some function safety that needs to be done at the OEM level?
Yes, calibration is also a factor for functional safety. If the function, if the when you go, we see basically the calibrations at software level and also at the point of sensors and actuators, how they need to function. So when it go into the production, we need to make sure that those calibration factors which are defined in the development need to go there, and in the end of line testing they need to do it. And
Perfect.
those things also they also need to mention that if this calibration is going to change during the time of the life cycle, then in service manual also they have to mention they have to recalibrate every time when it comes to the servicing for particular vehicle.
Awesome. Awesome. So I know that I said last question, but I still have two more
No,
questions
no, no
here.
problem, no
Since I
problem.
have
Yes,
time, I would like to take that up too.
yes, please, yes.
Where do you prefer the dependent failure analysis in the V model? Is it at the system level safety analysis or at the hardware or software level analysis?
Okay, according to the standard, dependent failure analysis is defined in the chapter 6, that is software development. But dependent failure can be identified in vehicle level, sorry, from the system level, software level, and hardware level. It depends. Why? Because dependent failures is how you are identifying the dependency, which methodology, which method you are following what. Okay, but dependent failures and cascading failures, you can identify them in the system level, software level, and hardware level.
Okay, perfect. One last question that I have is who derives the ASIL level? Is it OEMs or suppliers?
OEM is accountable for that SL rating, but we can, if it is a completely new innovation product or completely doing for the first time, then we need to give those inputs to the OEM to perform HARA analysis and give a particular SL rating. But at the end of the day, SL rating is accountable for OEMs itself.
Perfect. Perfect. Awesome. I think for the sake of time, I would like to wrap up the questions and we can go on to the next slide. And Ranjit, I know that you have one question, and Anish, I know that you wanted to talk. We'll complete the session and then we'll come back to you on the remaining topics. Uh, so I think you can stop sharing, Anudeep. I will
Yes,
start sharing from
yes.
my end.
I think I need to hand over the.
Yep. No, I think we are good. You can
Okay,
see my
okay.
screen now. Perfect.
Yes, yes.
So thank you guys, and I know that it was a really informative session from Anudeep. Thank you so much, Anudeep. That was really informative. The topics that you talked about, it was really good and very depth in concept. So the next point that we wanted to talk about, or rather, I would say, share our learnings is uh, creating an integrated process framework is very important. We talked about the functional safety. We talked about the challenges in the functional safety. We talked about the roles and responsibilities, the competency matrix, and the framework. We talked about it from function safety perspective. But the one key challenge that we face when we do the consulting is there are different standards in the market. There is a sort of standard, safety intended functionality, and there is like functional safety, which is like 26262. We have cybersecurity, which is ISO 21434. And then we also have some more standards like IATF 16949, and then we have ASPICE, which is the automotive spice, which is the base part of it, right? And in our experience, what the approach that we take when we provide consulting for the customers is, when you define a process, it's very important that you need to have the process integrated. So in our experience, what we have seen is, we see that all the teams are working in silos, right? There is a team that is working on automotive spice implementation. There is a quality management system. There is a process for it. There are templates for it. And then there is a team for functional safety who is working on it. And there is a team for security, which is the cyber security, who's working on it. So we see different teams working in different silos. And what we do is, when we provide consulting to the customers, we always start with an integrated process, and that's exactly what we are going to talk about in next few slides. And this is just a demo to show how we can tie the processes, and this is for the concept phase, right? I just wanted to show you an example on how this really works out. Let me explain the legends on what you have here in the slides. On the left side of the screen, you see the standards that's been currently used in the automotive. You see automotive spies, you see cybersecurity, which is 21434, and then you have the functional safety, which is 26262. And then here, wherever you see a orange block, this means that the processes are common. We are trying to create a common process which can be implemented or complied to all the three standards. And whatever you see here on the top, on the middle, center, and also here, these are the standalone processes or standalone requirements that needs to be implemented for the respective models. And to give you a quick example on how this looks like, you actually should start with the DIA, a development interface agreement. So in common terms, if you wanted to, or in a layman term, I would call DIA as a RASI chart, right? The roles and responsibilities chart. So you need to have a clear DIA, which is the development interface agreement, and this needs to be established in a OEM and tier one scenarios. The problem that we see in the market right now is, you have OEMs, you have different tier ones and suppliers working with the OEMs. If you don't have this piece of the DIA agreed with the suppliers, there is a high chance that you may run into issues, and then you may have to go back and fix those issues, which means that the rework effort or the cost of poor quality is very high. So that's the primary reason why we always emphasize that you need to have a DIA, which needs to be agreed with the customer, agreed with the supplier, and signed off as a starting point. And then followed by that, you also have the item definition. If you know the concept of cybersecurity, which is 21434, very well, even to do the threat analysis and the risk assessment, you need to identify all the items, right? So the item definition is a common thing that you have to, common activity that you may have to do for both functional safety and cybersecurity. Followed by that, you have the HARA, which is the hazard analysis and the risk assessment. And then from there, we derive the safety goals, and then the functional safety concept, technical safety concept, and then the safety requirements. Here we have the threat analysis and the risk assessment. As part of this, what we do is we derive the security goals, and from the security goals, we derive the security requirements. And then this flows down to the customer requirement, where the customer requirement will be a combination of both safety and also security. And that will be that will further flow down into the system and subsystem, or the software and hardware requirements. Now, whatever I see here in the block in the bottom screen, these are the supporting processes that you have to take care to implement the engineering processes better in your product, right? You should definitely have a good change management framework. You need to have a problem management framework. You need to have a good quality assurance function. You need to have a good configuration management. And the two key things that you have to keep in mind is, you need to have a common framework for audits and assessment, because at regular phases of your product development lifecycle, you may have to do audits to make sure that the processes, whatever you have defined, is being implemented in your product or not. And then you may also have to do some assessments against the model. For example, you may have to do an assessment against the function safety, you may have to do an assessment against the cybersecurity, automotive spice. So we need to find out a common framework that will kind of address both the audits and assessment in one simple checklist, an integrated checklist that can be used to verify the compliance to the standard, and also compliance to the internal processes, whatever you have defined. And also, it is very important that you need to have a common framework for the risk management and also technical review. So this is a concept phase. This is for the concept phase in the product development lifecycle. and we have implemented this for a variety of customers, and we have seen a lot of benefit, and we avoid rework. By this approach, we are trying to have one quality management system, one process which covers all the factors that we are looking at, and one template for system requirements of a system architecture design. And you don't need a two different templates, right? I mean, I'm sure you would agree with it. Ideally, when you talk about the concept of system architecture design, you don't need a one template for the function safety and one template for the automotive spice. So the architecture design, where we define the interfaces between the system elements, should be one, where you also try to address the concept of freedom of interference and other factors which is required from the function safety perspective, but the work product should be one. And that is exactly what we are trying to achieve here, and we have done this successfully for other customers. And to show you some of the examples, this is a perfect example of integrated development interface agreement that I was talking about. Here what we need to do is we need to list down all the activities and tasks that needs to be done, not just for the safety but also for the security, and also for automotive spice at the product development level. And then you define the roles and responsibilities on who's responsible for this activity, and get an agreement or sign off with OEM and tier 1, so that you have the roles and responsibilities clearly defined and you don't have any conflicts there. And the next example that I wanted to show you is the integrated project plan, where we have the complete, a laundry list of items, right? All the activities and tasks that you have to do for the project. That includes the safety, security, and also automotive spice for the product development. So we need to create an integrated framework that will kind of address all the three areas in one plan. And the third example that I have here is with respect to the project case. There was one question on the project case, and that's the reason I was holding off with the question. When you talk about the project case, both at the system level and also software level, we need to identify all the list of work products that we prepare for the product, and we need to have an argument clearly defined for each of the work product. And this needs to be done for both safety and security, and this is very, very important. And this will also help you to address the this can be treated as a configuration item list when you go for the automotive spice implementation. So again, the point here is to see how we can create or how we can integrate or tie back all the processes into one framework that can help you to implement the processes better. And the next example that we have here is with respect to the verification method. And you know very well that when you look at the verification, when you talk about the function safety, there are different verification methods. For example, we need to do fault injection testing, you need to do a resource consumption testing, or requirements-based testing, equivalence partitioning method. There are different verification methods that's been prescribed in the 26262 for different ASIL levels. In addition to that, when you look at the security perspective, you need to do a penetration testing, you need to do a fuzz testing. So these verification methods can be commonized, where we can have an exhaustive list of all the verification methods, where you can choose based on the level of, based on the ASIL level. We can definitely choose the amount of, the rigor of verification that you have to do for a product. And last but not least, I also wanted to highlight on the audits and assessment. We need an integrated audits and assessment framework that can be used, where you can verify the process compliance, and also you can ensure that your product is compliant to the standards like automotive spice or function safety or cybersecurity. So the idea here is we always emphasize that you need to have an integrated framework that can help you to achieve the compliances. And let's say that right now you have created an integrated framework which is compliant to automotive spice, function safety, and cybersecurity. And tomorrow, if you wanted to add in a new standard, well, let's talk about UNECE standard WP29, which is again a cybersecurity standard. So if you wanted to add a new standard, then always it will be like a plug and play approach, where you can include or enhance your processes to meet the new standard. So your base would be, or your base processes would be complied to automotive spice, function safety, and cybersecurity, which can be further enhanced or extended to other models. So we just wanted to show you this. And as a final slide that I have here, why do we need to have this plug and play approach? Why do we need to have this integrated process framework approach? Well, this framework is a very flexible framework that is easily customizable and tailorable, considering the scope and the scope of the product, what exactly you're executing, and the customer. For example, if you're working on a product which is very specific to BMS, a battery management system, right? Then you understand what is your scope in the BMS. Is it just system, or you're going to be working on the system and software, or the hardware is also included? So depending on the scope of the product, you can easily customize it or tailor it and use it in your product. And then there are no more silo approaches. You don't have three different processes, and I'm sure you would have seen in your organization too. One process is for one different QMS, a quality management system for ASPICE, one for function safety, one for cybersecurity. We need to have an integrated approach, no more silo approaches. We will avoid the rework by understanding the interfaces and touch points. And this is very, very, very important. I mean, how the processes talk to each other. That's the key part that we're trying to address here. That's the key challenge that we're trying to address here. With this integrated framework, we are very sure that the rework effort that you're putting in will be definitely avoided, because we are creating a tight knit processes between the automotive spice and function safety and cybersecurity. And we can deliver a quality product with no more hassles. Yeah, of course, we mean it. And then we have a clear roles and responsibilities with no ambiguity. And this is very, very, very important. And these roles and responsibilities will be a master RESI chart, the roles and responsibilities chart, where it includes the activities of the product development lifecycle, and also it talks about the safety activities, it talks about the security activities. We talked about the role of a function safety engineer, we talked about function safety manager. And there was a great question which was asked, have you seen this role of product safety manager? Yes, of course, yes. And this is where the ambiguity comes in, where if you already have a product safety manager and a function safety manager, what is the responsibility of a function safety manager versus the function safety manager versus the product manager is not very clear in most of the organizations. To reduce that ambiguity, we need to make sure that the roles and responsibilities are very clearly defined, agreed internally with all the system, with all your functional teams, and then you need to roll it out and implement in your projects. So we just wanted to share those lessons learned with you all, so that you can understand the importance of the integrated processes. And this is purely based on the learning perspective for you to understand on how we can tie back different models. We can tie how to tie back the different processes to get a better product, the quality, whatever you are expecting. So this is I mean, this is by this we are coming to the end of the session. Let me go back and see if I have any more questions that you would like to take at this point of time. Um, so Anudeep, one question for you.
Yes, Ram. Now I can hear you.
All right. So the one question that I have here is, um, uh, let me go back to the question. So there was one point that was raised by Saurav. Let me read through that, and then I'll come back to the question. Please
Sure.
let us know the sessions conducted by not tech in advance. If you can get a complete list of all the events that we launch in a month, it will be very easy for the participants to plan well ahead and do it. Of course, yes, Saurav, we'll definitely publish the list well ahead, for the particular month, so that you can be part of this and then you can take part in this for sure. And Ranjit, so there is a question from Ranjit. I would like to
Mhm.
understand the how to use the proven in use argument about the systems not developed according to the 26262. I think he's talking about the arguments, the safety arguments.
Yes.
And
No, we cannot. We cannot. Why? Because if it is not developed according to the ISO 26262, we cannot use the general arguments as for the to say that we have something safe.
awesome, great. I mean, there's one question from Sandhya. Can product owner be the safety manager? In your opinion, do you think
Yes,
it makes sense?
if they have those competencies, yes, he can be. He or she can be.
Yep, perfect. Let me see if I have any other question here. There's one question from Pradyumna. I think that is more on the integrated approach. Is plug and play framework feasible for the component level safety and security? Of course, yes, Pradyumna. The example that we saw right now, it is more on the concept level, but even at the when you I mean when we broke it when you break it down at the composition, when you do the decomposition of the system, right? when you decompose the system into subsystem and subsystem to systems and software, the integrated framework that we have defined will be applicable even at the component level to ensure the safety and security. So to answer to your question, yes. There's one question from Dinesh. Do you support in external FuSa audits? Yes, Dinesh, we do. We definitely do support for sure. Um, I think I'm trying to answer all the questions that I have here. There's one question. Thanks, Pradyumna. Thank you so much for that. Okay, there's one question from Manik. When I'm having an ASIL B wheel speed sensor as a requirement for an ECU of a ASIL D
Mhm.
output, what should I do when I get the QM wheel sensor?
Oh, that's where the SL decomposition comes into the picture. But if you have SL B speed sensor and
ASIL
you're
D
getting
and then
SLQM,
QM.
okay, B of D plus QM of D we have to do, but it is not recommended SL decomposition combination.
Yes, it is not. Yes. Uh,
You can do it, but it is not recommended.
That's a great question, though, Manik. I mean, that's a great question, though. Uh, and there's a question which has been asked. Okay, what is the difference between an audit and assessment? That's a great question. In fact, I mean, I wanted to talk about it, but somehow it was missed out. So when you talk about the audits are usually done against the processes that has been defined internally, right? It's against your processes or QMS that you have defined internally. When you verify the complaints of the implementation against the processes, whatever you have defined, it's an audit. And when you talk about the assessment, it is always done against the model. For example, it is always done against the function safety model, ISO 26262, or ASPICE, or 21434 standard. So it is against the model. So that's the key difference between the ASPICE and function safety. Let me see if I have any other question. Guys, just to let you know, I will definitely publish the list of events that we are planning to do well in advance so that you can be part of it for sure. And just to let you know, we also do a lot of workshop. We also do a lot of coaching program, and we have a coaching program in 2 weeks that we are planning to do, and it's a 2-day coaching program for function safety, and the focus is more on the function safety engineers and managers, and we are trying to. It's not like a theoretical program that we go through. It will more of a hands-on experience where we provide the know-how on how to implement the function safety in your organization with real-life examples. And for example, we'll be talking more on the HARA, how to derive the safety goal with a live example, technical safety concept, and function safety concept. So I just post the link down, and if you are interested, please enroll and then drop us a note, and then we will definitely get you enrolled. Um, with this, we are trying to let me see if I have any other question that we wanted to take before we wrap off. Guys, do you have any other question that you wanted to take? Let's post down here. Great question. I mean, on the recording part, unfortunately, we cannot share the recording, but we will definitely share the copy of the presentation if you like to have one. But if you have to drop an email to me, and then I will post my email ID in the chat box for presentation materials. Please drop a mail, and then I will definitely ensure that we ship the training material to you for sure. I mean, the material that we talked about for sure. And the next event, I mean, we don't just focus on the function safety. We The next event is more on the automotive spice, which will be again planned in the 2 weeks period. If you can drop us, and we'll definitely post in the same group. We are planning to do a workshop on the automotive spice, and on that, I mean, the topic that we have chosen is more on system architecture design and how what is the expectation from a spice perspective on system architecture design and so on. So if you are really interested, please do enroll, and we will love to take you in, and we'll love to include you in the program for sure, in the webinar for sure. But having said that, we wanted to do this every month. I mean, based on the response, whatever we get, we wanted to do this every month. Please do drop us an email with all your feedback, and then it will definitely encourage us to do more and more sessions where we will bring in experts to talk about different topics and share knowledge. That's the intent of it. So, Anidip, do you
Uh,
want to do? Yeah.
Yes, I'm sorry to interrupt. There is one question from Hemant. He's asking regarding the if the functional safety is improperly implemented at the software level, and if the calibration can still is the requirement of safety. Is it still go ahead? See, the word, I mean, improper implementation means the technically implemented wrong, or there is no, I mean, you did not follow the process, but you implemented it right in the software. Is that the meaning of it? See, if you implement it, improper implement means that's a little bit vague, Hemant, to justify the question. But if the calibration is, if there is any mistake from the calibration point of view, I wouldn't. I mean, usually the functional safety manager will not give a go ahead.
Sure.
Which,
I
if
hope
it is
that
affecting safety functions, sorry, Ram, if it is affecting safety functions.
perfect. Awesome. So I have put on the link if you wanted to enroll in the 2-day coaching program that we conduct for function safety. Meanwhile, I will like to unmute Anish. I know that Anish had a question, so I'm going to unmute Anish. And Anish, you can talk now. You can unmute yourself and then you can talk. Anish, you there? Right, there's one more question. Um, while we wait for Anish to join. FuSa at software level is blinded by, I think it is more of a statement, sorry. Um, I agree, Rao. I think FuSa at the software level is blinded by the SMPU. I completely agree with you. Yes, you're right. I know that you had technical difficulties in joining in, guys. I know that it was not great. And this is like a first session, right? And we will definitely solve this out going forward. So sorry for all the trouble. Apologies for all the trouble that you had joining in. I think we have pretty much addressed. Okay, it is not a question; it's more of a statement. Yes, you're right. I figured that out. So, great guys. I think it was a great session. I don't see another question here. Thank you everyone for joining in, and let us know your feedback. Please drop us an email, and please let me know your feedback. And we will definitely do this on monthly basis, and we will definitely publish the content, publish the schedule well ahead in advance, and we will let you know so that you can be part of it for sure. Anudip, do you wanted to give a closing note?
Yes, thank you everybody, and looking forward for the coming sessions also, how we can address different points in the functional safety, and have a good discussion on that area. And I really appreciate everybody joining this discussion, and have a nice weekend.
Yep. Thank you everyone. Have a nice weekend and take care. Thanks for the enough. Thank you again. Bye.